Friends, this is B. Praveen Kumar, a lecturer in chemistry, Government Degree College, Gambhirapet, Rajanna Sirisila District, Telangana State. In this class, I am going to discuss mass spectrometry. So, actually, what is the use of mass spectrometry? We can find out the mass of the compound and we can easily go forward in the reaction process. So, it is the main theme and main advantage of the mass spectrometry. Here in this slide, I have tried to explain the principles of the mass spectrometry. So mass spectrometry is the most accurate method for determining the molecular mass of the compound, its elemental composition, the compound and its elemental composition. In this technique, molecules are bombarded with a beam of energetic electrons. In mass spectrometry, we do not use any kind of electromagnetic radiation or other else, but the technique is molecules bombardment with a beam of energetic electrons only. So we are not using any type of electromagnetic radiation, but we are using the electrons to bombard with the molecules. The molecules are ionized and broken up into many fragments. This is the main principle of the spectrometry. Molecules are ionized and broken up into many fragments. Fragments, which, as we know, fragments is called as pieces or branches, some of which are positive ions. In that fragment, some of are positive ions. Each kind of particular ion has a particular ratio of mass to charge. Mass to charge means M by Z ratio, that is called as mass to charge ratio, or M by Z value. We can call it as M by Z value. That means each kind of particular ion has each kind of mass to charge, that is M by Z ratio. Next, the molecule ion is called parent ion and is usually designated as M plus ion. Molecular ion is called as parent ion and is usually indicated as M plus ion. It is positively charged molecule with an unpaired electron. So, we would like to explain the molecular ion. It is completely positive charged molecule. It has an unpaired electron. The set of ions, fragment ions or daughter ions, are analyzed in such a way that a signal is obtained for each signal represents the relative abundance of the ion producing the signal. Relative abundance. Next, the largest peak in the structure is called as base peak and its intensity is taken as 100. Whichever the largest peak is, whichever the peak is largest in the structure, that is called as base peak here, and the intensity is taken as 100. The intensities of other peaks are represented relative to the base peak. The intensity of other peaks are represented relative to the base peak. Next, mass spectra is used in two general ways. In this slide, we can see the uses or advantages of mass spectra. It is used to prove the identity of two compounds. It is used to prove the identity of two molecules, identity of two molecules, and it is used to establish the structure of a new compound. Here, not only to determine the mass, it also used to prove the identity of two compounds. It also used to establish the structure of a new compound. The theory of mass spectra. A parent ion results when one electron is removed from the parent molecule of the substance. When will the parent ion forms and where it is formed? Means if an electron is removed from the parent molecule or a compound of the substance, then a parent ion results. Then the parent ion is formed. The M/Z value of the parent ion is equal to the molecular mass of the compound. Here it is the most important point. The M/Z value of the parent ion is equal to the molecular mass of the compound. What is the molecular mass? Means whichever the M/Z value of the parent ion concerned, that is equal to the molecular mass of the compound. In a few cases, the parent ion peak may be the base peak and can be easily recognized. In most of the cases, parent ion peak is not the base peak and is often of very small abundance. So it is not necessary to be the base peak. It is not necessary that parent ion peak is to be the base peak or not. Parent ion may be the base peak or may not be the base peak here. Many elements occur naturally as isotopes. Out of these, the lightest one greatly predominates. Many elements occur naturally as isotopes. Out of these, the lightest one greatly predominates. The mass spectrometer is designed to perform three basic functions. So, why the mass spectrometer is designed means to perform three basic functions. One is to vaporize compounds of varying volatility, to vaporize compounds of varying volatility, to produce ions from the neutral compounds in the vapor phase. Next, the third one is to separate ions according to their mass over charge ratio and to record them. Especially this is the most important point, to separate ions according to their mass over to charge ratio and to record them. The plot of M/Z value taken along abscissa and their relative intensities along the ordinate is called the mass spectrum. Hope this is the example of mass spectrum. Here, a y-axis, we are taking relative abundance, while the x-axis is M/Z values. Here, M and base peak, the largest peak is the base peak here. So, the parent ion, it may be the parent ion or not. Whether it may be a parent ion or may not be a parent ion. So in this way, the mass spectrum will be here. This is another example. This is the example of toluene. So left side we can see the values of relative abundance that is in the percentage. At y-axis, here MBZ values are there. So this is the base peak at the 90. There is the largest peak, that is base peak. So this is the MBZ values. This is the plot of relative abundance versus MBZ values. This is another example here. Mass spectrum of hexane. Here, this you can see here clearly. The molecular ion MBZ value is 86. This is the parent ion. Here you can see base peak is the largest peak, so that is MBZ value is 57. But the molecular ion MBZ value is 87, 86 I think, 86. So this is the mass of the compound. This is the mass of the compound. So molecular ion base peak, M plus 1 peak, or molecular ion peak, the MBZ value of molecular ion is equal to the mass of the molecule. So here we can see the molecular weight of hexane is 86. So the molecular ion MBZ value is also 86. Here you can see clearly the molecular ion for hexane is at MBZ is equal to 86. The base peak occurs at 57, and molecular ion M plus 1 peaks occur at 87. This is the McLafferty rearrangement. This is the carbonyl compound. In carbonyl compound, it is divided into ethane, that is doubly bonded carbons are there, alkene plus enol radical. The carbonyl compound has been divided into two compounds, that is one is ethene, that is alkene, and enol radical, another, that is cation. So here we can approach, or we can explain the McLafferty arrangement by the alpha, beta and gamma bonds. So here the gamma can be hydrogen. So here Y is there. In the place of Y, that it can be hydrogen or alkyl group or OH group or hydroxy group, whatever it may be. So the carbonyl group or carbonyl compound converts into alkene plus enol radical, that is cation. This is called as McLafferty rearrangement. So the McLafferty rearrangement is a reaction observed in mass spectroscopy during the fragmentation or dissociation of organic molecules. It is sometimes found that a molecule containing a keto group undergoes beta cleavage. Here, a keto group is undergoing beta cleavage with the gain of the gamma hydrogen atom, as first reported by Nicholson, working in the Division of Chemical Physics at the CSIRO in Australia. So here the beta cleavage with the gain of gamma hydrogen. So we should call it as McLafferty rearrangement. So with this I conclude the main principles of the mass spectrometry. Just I expressed the fundamentals or some basics of the mass spectrometry. Mainly, what are the advantages, what are the uses of mass spectra, some of the mass spectra examples, like one general examples, and one is toluene, and I explained the definition of molecular ion, base peak, parent ion, MBZ value, etc. And here I also expressed the what is McLafferty rearrangement. So with this I can conclude. Thank you.